It is 11:47 p.m. on a Friday. You just pushed your new API to production, and everything works perfectly in your API client. But the moment your frontend tries to call it, the browser console lights up red. You know the error by heart. You have seen it 100 times, so you do what every developer does. You copy the same fix from the same top-voted answer you have bookmarked for 3 years. You paste one line of configuration and go home. And that one line just opened your API to the entire internet. Every web developer has memorized this ritual. The browser says no access control allow origin header is present. You do not read the core specification. You do not investigate why the browser and your API client behave differently. You open the first search result, scroll past the accepted answer with over 1,000 upvotes, copy the magic incantation, paste access control allow origin :* into your server configuration, and the error disappears. It feels like a victory. The console is clean, the request succeeds, you move on. Here is what textbooks and framework quick-start guides tell you. CSRF is a browser security mechanism. The same origin policy prevents one website from reading data from another website. To allow cross-origin requests, the server sends back a header that says which origins are allowed. If you set that header to a wildcard *, any website can call your API. And for a public API that anyone should be able to access, that sounds reasonable. On paper, it is perfect. But here is the lie that star hides. The core's wildcard is not a permission toggle. It is a sledgehammer, and it breaks in ways that are not obvious until it is too late. The first crack appears the moment you add authentication. You configure your API to accept a session cookie or an authorization header. Suddenly, every request from your frontend fails again. The browser console shows a new error. The core specification has a hard rule. If a request includes credentials, cookies, TLS client certificates, or an authorization header, the server cannot respond with a wildcard origin. The wildcard and credentials are mutually exclusive by design. So the fix you copied from the top search result does not work for any API that actually needs to know who is calling it. The second crack is worse. Even when credentials are not involved, that star tells every browser on the planet that your API welcomes requests from any website, any phishing page, any malicious ad, any compromised forum. Every one of them can now make authenticated requests to your API using the cookies sitting in your users' browsers. This is Cross-Site Request Forgery, and you just handed it the keys. The third crack is the one nobody talks about. That star disables all Preflight caching. Every cross-origin request to your API now triggers an options Preflight round trip. For a single request, that is 50 milliseconds you do not notice. For an application making 40 API calls per page load, that is 2 extra seconds of latency that degrades silently in production, while every synthetic benchmark in your CI pipeline reports green. The real fix is not a wildcard. It is an origin whitelist that the server validates dynamically on every request. Here is what senior engineers actually do. Instead of hardcoding star, your server reads the origin header from the incoming request. It checks that origin against a known list of allowed domains. If the origin matches, the server echoes that exact origin back in the access control allow origin response header. If it does not match, the server returns no core's header at all, and the browser blocks the request. This is called origin reflection with validation, and it preserves the security boundary that the star destroys. For credentialed requests, you also set access control allow credentials to true. The browser will only accept this if the origin is explicit, not a wildcard. This is the specification working as designed. For the Preflight overhead, you add an access control maxage header. This tells the browser it can cache the Preflight response for a set number of seconds. For most APIs, setting this to 3600, 1 hour, eliminates Preflight requests entirely after the first call. And for the CSRF problem that the wildcard created, you pair your core's configuration with SameSite cookies set to lax or strict. This ensures that cookies are only sent on SameSite requests, even if the origin header is spoofed by a malicious page. 3 headers, an origin whitelist, a SameSite cookie. That is the difference between a core's configuration that looks correct and one that actually is. The wildcard star is not a fix. It is a deferred security incident. Next time you see that red core's error in the console, do not reach for the bookmark. Reach for an origin whitelist, validate the origin header, set max age, and configure your cookies. Your users will not notice the difference. Attackers will.